Okay, the second case that we will be discussing is when the standard deviation of the population is unknown. So in this case, the critical value will not be the z value, it's going to be the t value. And the t value is taken from a family of distributions. We call them students t distributions. They're a family of distributions, not just one. And these family of distributions, they depends on something we call degree of freedom. As the degree of freedom increases, the distribution becomes more normal, more close to the z, to the normal distribution. So this t distribution is actually Isabelle-shaped and symmetric, exactly like the standard normal distribution. However, the greater area becomes more in the tails. And as we said, the distribution becomes closely, really, copying of the z distribution as the degree of freedom increases. What's the degree of freedom is n minus k, n is the sample size and the k number of parameters that we are estimating. In this case, we are estimating only one parameter, which is the mean or the proportion, so it's going to be n minus 1. So the degree of freedom is going to be n minus 1. So what is the t value for the x bar? If you remember, we used to find the z value, the standardized value of the x bar, right? Which is this. This is from chapter 7. So the t value is going to be, and actually if you remember, this is equal to x bar minus mu by the central limit theorem, and this is sigma over radical n. But now we're looking for the t value, not the z value. So the t is the same. Look, they are similar. The only difference is what? Sigma and s. What is s? Is the sample standard deviation. Is the sample, so we are using sample standard deviation. Look at the green one is the t, and the brown one is the standard. And as I said, look at the tails. They have more probabilities in the tail, more area compared to the brown one. So what is the confidence interval? The confidence interval when this guy is unknown. So it's going to be, again, is the point estimate plus minus the margin of error. What is the point estimate? Is the sample mean plus or minus the critical value, which is the t value, times the standard error. What is the critical value is t. What is the standard error? S over radical n. What is the sample mean? X bar. Well, you have to be careful about the t value. You have to consider the degree of freedom, which is n minus 1. Why minus 1? Because we are estimating only the mean, the population's mean. Example. Eastern Automotive Protection Sales and Services extended warranties for vehicle owners. The company also operates a service center where employees respond to customers' calls with inquiries about their warranty contracts. Recently, a team of Eastern employees was asked to determine the average length of time service representatives spent with customers. The team decided to collect a simple random sample of 25 calls. This is a very important piece of information. Because they want to know the average length time that the service takes with customers, so they can't access to the population, the whole population, then they got a sample, which is n equals 25. And the goal is to estimate the population mean call time. This is the goal based on the sample. So let's look at the other data that we are given. So this is the sample. So I have a 25, n equals 25. And we got the call times, and this is very simple. We can use Excel to find the average of these guys. Because look, before doing any of this, the goal is what? The goal is to find the confidence interval. What is the confidence interval? It's the point estimate plus or minus margin of error, which is the critical value, times standard error SE. The point estimate is x bar. The point estimate of the population mean is the sample mean, which is x bar, plus minus. What is the critical value now? The critical value, is it t or z? It's t. Why t? Because the population is not, the question doesn't say the population is, or the standard deviation of the population is not known. Actually, it says here, we don't know sigma. We don't know it. So that's why we use t. T basically assumes something, which is very important. To use the t, we assume that the population is normally distributed, and that's why we're going to use this fact. We're going to use it. Times the standard error, which is s over radical n. So if you look at the question gives you n, which is, what is n? 25. We have to get x bar. What is x bar? You can't take it from the sample. You just calculate the average. If you calculate the average, you're going to get 7.08 minute. Also, you have to get the standard deviation of the sample. You use Excel. S equals stdev dot s, all of the data. Then you get 4 minutes, 0.64. After you get x bar and s, then what you can do, you can basically use the fact to find these facts to find the t value, the critical value, right? So we can use the 95% confidence level, and we can use the degree of freedom df equals 25 minus 1, which is 24. All of these will help you to find the t value, the critical value. So the critical t equals to what? Use t dot env. If you remember in the past when we use the z, we use norm.s.env. Now we use t.env.2t, 2tail. And now we are going to use 1 minus the confidence level. Every time you use 1 minus confidence level, comma n minus 1, which is the degree of freedom. So let me plug all of these here. So what we get, x bar is 7, we use different color, so it's 7.088 plus or minus, what is the t? It's t.env dot 2t, 1 minus 95%, comma 25 minus 1, times the standard deviation is 7.088. Oh, sorry, it's 4.64. Is 4.64 divided by square root of 25. If you plug all of these guys, you get 7.088 plus or minus 1.915. And this is what? This is between 5.173 minutes to 9.003 minutes. So based on this random sample, 25 and 95 confidence interval, the Eastern team has estimated the true average time per call to be between 5.17 minutes to 9.00 minutes. I have space here. I don't know why didn't I use it. But yeah, so this is using what? Using the t distribution, given that the standard deviation of the population is not known. In the next section, I'm going to discuss the required sample size and for estimating the population mean.